my mic is off. Nako. All right, you're welcome to our first contact on this course, BDT 253, Pharmaceutical Calculations. So we'll start from what is pharmaceutical calculations? What is pharmaceutical calculation? You know, in your secondary school, your first year, the mathematics you did that time, general mathematics. Is general what? That was the general what? Mathematics. But now, let me borrow the word customized, or borrow the word denominated. So now, the calculation we are going to be doing here, the mathematics we are going to be doing here has to do with what? That has to do what has to do with what? Pharmacy. Am I communicating? Everything has to do with drugs. Okay. So this is the reason why you did what you did in your what? First year, even in your secondary school mathematics. All these things you've been doing will help you now. You apply the knowledge, your mathematical skills now in calculating, measuring, and the formulating, compounding, and dispensing of what? Drugs. Am I communicating? Yes. So this is what this course is all about. So what is pharmaceutical calculation? Pharmaceutical calculation is an area of study that deals with the application of basic mathematical principles. It's an area of studies that deals with the application of basic mathematical principles in the compounding, formulation, and dispensing of drugs and other pharmaceuticals. Is an area of study that deals with the application of basic mathematical principles in the compounding, formulation, and dispensing of drugs and other pharmaceuticals. So if you apply mathematical principles in these processes, you are doing what? Farm calc. So that time you have not started doing your practical. I think you start your practical this semester, right? You are dispensing practical. That time you are checking the quantity of the ingredient to use. You are doing pharmaceutical what? Calculation. That time, those that were privileged to work in maybe pharmacy before coming here, or those that went to, who are you? I advise you on something. I don't know who did it. Did you? How many of you went to a pharmacy doing your long back? Good. I like that. Good. I like that. You learned a lot, right? You appreciate what they're doing here, right? Good. I like that. It will help you. It will help you a lot. Now, those things maybe you saw them doing, or you did yourself, calculating number of tablets in a day a patient will need to take from prescription, the quantity to give, on how to calculate the dose from maybe the suspension in a bottle, how many ml the patient need to take, and all those things we are doing. You are doing what? Pharmaceutical what? Calculation. Now, so pharmaceutical calculation is applied even in the community pharmacy doing dispensing, okay? In the hospital pharmacy as you are dispensing, even in the compounding lab as you are compounding different dosage forms extemporaneously, even in formulation in big pharmaceutical companies where you manufacture in large quantities, the calculation you do there to be able to know the exact amount of each of the ingredients you need is pharmaceutical what? Calculation. Even when you package, you know how many that should be in a carton, how many carton that you should dispense, you should be able to do what? Take out. You are doing pharmaceutical what? Calculation. Those two human beings behind, I don't know what they are doing. So why are you laughing? Smiling. She did what? And you are smiling. So what did I say last? Tell us, stand up. Tell us what I said last. Oh yeah. If you don't say now, you leave my class. Stand up. Oh yeah. Tell me what I said last. Don't stand up. I said you should stand up. Tell me what I said last. If you're Maria, if I send you out now, you are crying for the first class that you are sent you not attend. Now a year another one has come. You're not having issues, so what issues now as early as possible. It's hovering around you now. If I send you out now, you have missed this class. What is it? In fact, come here. Come and stay here. Carry your come here fast. Carry your belongings and come here. I'm here talking, and you are here looking for who made mistake and who don't make mistake, and you are laughing in my class. Keep quiet and come here fast. Fast. You're holding this class at ransom. Let's continue. Don't sit there. I say here. Don't shift my camera. Sit there. Good. Where is your pen? Let me even see what you're writing. Open it. Let me see. Pharmaceutical calculation is area of studies that deals with basic application of mathematical principles. That's where she stopped. That's the issue. Leave my class fast. Leave. Leave. No remorse at all. She's arguing. Leave. Can you leave? Leave. Get out. All right, so let's continue. I sent her here. She's still arguing with me. No remorse at all. She saw nothing bad in what she did. And that's the worst that can happen to you. If you are corrected, you fail to see where you went wrong. One, she's laughing behind. Secondly, the division I gave 6, her own is not complete, but she's laughing. Okay, so even in the thing you are seeing now, the thing you are familiar with, the one that concerns you in PharmCalc now is just to be able to know the quantity of drug medicine to give to a patient, the dose and the quantity of ingredient used in compounding and formulation. But there are other ones beyond this scope. In fact, when it goes that if you go to pharmacokinetics, you now see another area where you see that is where you now see differentiation and integration. That's where you start that one start coming on. When you start going into half-life and other things, rates of reaction and other things, and the pH and other things, you start seeing all those ones. But the basic pharmaceutical calculation you need for you to work as a pharmacy technician, for you to interact with your patient, is just simple basic mathematical based on simple basic mathematical operations of addition, subtraction, division, and multiplication. In fact, the majority of what we are going to do here are mainly what? Addition, subtraction, division, multiplication. Mainly. And that's what you need to be able to do what? Serve your what? Patient. But when you start going into research, start going deep into pharmacy, maybe when you now start calculating the pharmacokinetic profiles of drugs, in drug discovery, in assaying, analysis, there are other levels of calculation there. There are also pharmaceutical calculation, but these ones I mentioned are just the ones you need, just addition, subtraction. So if you see me, that's why this course is very simple. It's for those that are not serious, that will have issues in it. They're nothing. It's just your normal addition. You know how to add now. You know how to subtract. You know how to multiply. Based on that, you start seeing things like ratio, proportion. If you know about ratios, proportions, variations, there's in fact majority of the calculations you are going to do in this course is based on what? Ratio and what? proportion. Basically, ratio and proportion. If you understand, if you know your ratio and proportion, even if you did not read the topic in FAMCAC, if you not read any topic in FAMCAC, and you have the basic understanding of ratio and proportion, and I give you, and you go to exam hall, you can score up to 60% if you know ratio, if you know ratio and proportion well, and you understand word problem very well, word problem application of mathematics. You know that there are some people that can say that they can solve equation that x square is equal to, they can solve all those things, but when you now make it as word problem, they have issues. That's where your understanding is tested. So if you can solve questions, what I'm trying to do, I'm trying to calm your nerves, so you don't get too, that's how you become too afraid. You start having issues. So but if you bring material today, you become tired because you have to you'll be afraid. Me, I will tell you that you write quiz on Friday, your mind just keep do. But I want to calm your nerves to tell you that it's easy and simple. All you need to do is just to be serious with your classes. And if you know you have issues in basic mathematics, please go back, review your mathematics. In fact, the first 4 topics in this course outline, you have the course outline, right? I'm giving it to you. The first 4 topics are just math review. In fact, there's some textbook you see, they call it math review. There's some pharmaceutical calculation textbook you see. What you see is what? Math review. Because they know that some people do not actually do mathematics, but they passed it. What a miracle. Yes, we are aware that some people did not actually do mathematics, but they passed it. So the person now comes in, starts to tell the person 1:2, as if people are like, I don't know what they're talking about, because on Maria, this person doesn't know it. So, and also those that are actually did mathematics, but maybe they have forgotten it, just to refresh your what, because you need them in the calculation. So the first topic, ratio, and the first topic is what? Numbers and numerals. Is math review. Second topic is what? Enumeration, right? And what? Notation. Math review. The third topic is what? Rounding, approximation, and what? Math review. The fourth one is what? Ratio. Those 4 topics are mathematics, pure mathematics review. To prepare you. But matter of them all is ratio, proportion, and variation. If you don't know ratio, forget it. Even if after teaching it here, you still don't know it, I'm sorry, you may not pass this course. But the questions you'll be seeing will be rooted on that what? Ratio. By time we start, you understand what I'm talking about. It's rooted in what? Ratio. Even if you don't know any other thing, no ratio. That's the foundation. Then from fifth topic, now you start seeing pharmaceutical what? Measurements. So you now enter into pure FAMCAC now. You start coming up to the last topic. So that's why you should be in the beginning of this course, take it what? From the beginning, take it seriously. So now this is a word of what? Introduction, okay? Now let's go to the first topic. First topic is what? Numbers and what? Numerals. Numbers and what? Numerals. Please, there's something I've noticed among this generation. Please listen carefully. The best thing, nobody is perfect in this life, okay? Even me. Sometimes I commit. My boss, my HOD will tell me, Chetana, immediately he knows me for that. Immediately he says, Chetana, I'll say, I'm sorry, sir. Admit it first. That is the positive mindset. That's positive mindset. We are here to mold you. Once we point out, I cannot be pointing things out because I want to talk. If I point, there's something you're doing that is wrong. Your parents sent to here for us to mold you, two of us. Then it's our duty to see those things and point it out. And when we point it out, the first thing is to say is, first of all, say, if you are properly trained, the first thing is to say, I'm sorry, sir. So we even go to the lesson and say, thank you for the correction. Yes. That's the mindset to learn. That's the mindset. Not to be agreeing. What are you agreeing about? I don't know. Why I say this is for those that are here. She's having her punishment already. It's for those that are here so that you learn to do things. So numbers and what? Numerals. From your, you see, someone is not school, not nursery school, daycare. Ntaka, can you get ntaka yawa? I was ntaka. Ta, you guys, ntaka yawa. Never get ntaka. Ta, ibu slate. Ibu slate. You blow slate now. You blow slate. You blow slate now. You blow slate. So from that level, you've been talking about numbers, 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 numbers. Now I want to ask, what is a number? Who can define number for me? If you ask now, as you are as old as you are called out, what is a number? What will you say? Oh yeah, I'm listening. Oh, what's the figure? I'm listening. Who will tell me what a number is? Fast. It's a digit. Okay, now. Another person. Are you for real? Superb, so who will tell me what's the number? She asked, is there a definition for number? Yes. Okay, say it. Let's hear you. Say it.
Expressed by a word, symbol, or figure, representing a particular quantity and using counting and making.
It's okay. I like that. It's okay. It has some points in what I want to say. It's good. It's not bad. Any other one? Say it, teaching and say it. That thing I become to them and say it. Let me hear you. Okay, now let's go. So let's not waste our time. Now there's something I want you to know. Number is abstract. Basically, number is abstract. It's an idea you conceive in your mind. Any idea you conceived in your mind, you used in counting or measuring. Any idea you conceive in your mind, you use it for counting or measuring or measurement. That idea is a number. So what's a number? As I said now, a number is an idea. Of course, being an idea, hope you know that an idea is abstract. Hope you know. Can you touch an idea? Can you touch idea? So idea is abstract, right? So a number is an idea conceived in the mind, using what? Counting, right? And measurement of what? Quantities. Counting and measurements. Do you know why I say counting and measurement? You know, there are some numbers that you can count. Like now, as it is now, this thing, there are five markers here, right? I can count 1, 4, 2, 3. As I'm counting this thing, the idea of that this is 1 is in my mind, true of us. The idea that this is the second one is in my mind, true of us. That's why you can count it in your mind, even without saying it, right? There are 4 of these, right? Then you can also serve as measurements. Maybe you put a metric rule here. From here to here is 5 centimeter, right? You're measuring it. Can you count centimeter? But you measure it, right? So that's where I said counting or measurement of what it is. Am I communicating? Now, what is the relationship between numbers and numerals? Do you know the relationship between numbers and what? Numerals. Now let me explain. Even though I want us to discuss numbers first before we go into what? Numerals. But let me just say one thing. What I want to say about numerals will help you understand numbers. Now, Numbers, as I said, that numbers are what? Ideas or what are what? Conceived in the mind, right? Using what? Counting or measurement of what quantities. And is represented by what? Numerals. Numbers are represented by what? Numerals. Number is the same everywhere, worldwide. So far, you're a human being that reasons. Number is one. That idea you have in mind as one. A Chinese man is also one in his mind. An Indian man is also one in his mind. Someone that you don't even speak the same language to, you don't know the two of you don't understand the same language. But two of you, if you line up people from different races here, about 5 races here, and get this marker and place in front of them 3 of them, in their mind they will all have three in their mind. 3 of us, yes. A Chinese man will not have 2 in his mind. 2 of us. An Igbo man will have 3 in his mind. At all. Now, but how, if you now want them to write down what they conceived in their mind, the way they will write it down or say it will do what? Differ. They will represent it in different ways. But it's the same quantity they counted in their mind. But they will represent that same 3 different what? Ways. Now, what you now use to represent these numbers is what we call what? Numerals. Are we together? Are we together? So, that relationship between numbers and what? Number is number. But numerals differ. We have different numerals. We have Roman numerals, Arabic numerals, Chinese numerals. There are numerals can come. But the one that have conquered the world are 2 numerals. Roman numerals and what? Arabic what? Numerals. Am I communicating? In fact, the one that is popular, the most common we use here around us is what? Roman numerals? It's Arabic now. You are 1, 2, 3 is what? Arabic numerals. But Roman is what? Are we together? We will treat numerals when we get there. Just mention it to help us understand what? Numbers. What we are treating now is what? Numbers. So let's now continue with numbers. So having explained, you now have a basic understanding of what numbers is. Right? So you can define numbers now, right? I'm up here. Good. Now, let's continue with numbers. Now, when you come to numbers, basically under numbers we have 2 major types of numbers or categories or classification of numbers. 2 major ones. We have the real numbers and the imaginary numbers. Real numbers and what? Imaginary numbers. We have what? Real numbers. Number is here. We have what? Real what? And what? Real numbers and what? Imaginary numbers. So, what are real numbers and what are imaginary numbers? Now listen. All the numbers that represented in the number line, you know what number line is, right? Yes. That start from negative infinity, 0 to positive what? Infinity, right? All the numbers that find their place in the number line All these things, the numbers you are seeing on the number line, both the one you can see and the one you cannot see in number line. Hope you know that there are numbers you cannot see in number line. Now let me draw number line and use to explain what I mean by real numbers. This is number line, right? And this is negative what? Infinity. And this is what? Positive what? Infinity. Now, 0 is at the what? Middle. So whatever you can start from any, this means agu, right? On ending. You can just start here as what? 6 minus 6, okay? Minus 4, minus 3, minus 1. Here is 0, right? Here is what? 2, 3, 4, 5, and so on. Now, all the numbers here, this one you are seeing with your eyes, there are millions of numbers from here to here. You can't see them unless you want. In fact, you can't even see them unless you want to represent them. There are some that you cannot even represent. By the time we go into the numbers, you understand. All numbers on the number line are called what? Real numbers. Are we together? They are real numbers. Now, we have the one I call imaginary numbers. Those ones are used in some fields mainly. They are used in some fields. Something like what? Maybe BI, or let's say I, something like what? 3I, something like this. Am I communicating? Yes, sir. Now, those in engineering, computer, we know much about it. We don't use them here in our side, okay? We don't have much to do with it, but I want to mention it in case you see yourself, you see it tomorrow, you know what it means. And also set 1 or 2 questions from there, because I'll test you on what I've said in this class, okay? Now, actually, this I means root minus 1. This I means what? Root minus 1. So square root of minus 1. That's the meaning of I. Now, sometimes real number combine imaginary number. So real number combine with imaginary number to form what we call complex numbers. Real number combine with what? Imaginary number to form complex. So imaginary number is real number plus. So complex number is real number combined with what? You see something like this: 2 plus 3i. This is a complex number. This is a complex what? Number. This side is what? Real. This side is what? Imaginary. Are we together? So generally, you see something like this. Generally, a plus what? B what? I. This is a complex number. So imaginary complex numbers is not. We don't have much to do with them. I just mentioned it, but our focus is more on this what? Real numbers. So under real numbers now, I will now use this number line to explain real numbers. So under this real number now, we have the one that are discrete and one that are what? Continuous. So under real number, we have discrete numbers and we have the what? Continuous number. Now look up. I want you to understand this. Let me clear this so I don't cover the topic. Now look up. Can you see the board from there? This side? Okay. Now, I said that under real numbers we have the what? Discrete and what? Continuous. Now, what are these discrete? The one that are distinct, bam, are what? Discrete. You can count them easily. Any number, you can count them